All right, class. Sorry it's so late. We're going to start on page 88. This is, I believe, number 39. This is the problem that they were talking about the molecular mass, the molecular formula, empirical mass, empirical formula. And so on this problem, let's go ahead and write out all the things that we're going to need, that we're going to use. So first and foremost, we're going to need the molecular formula. And then we're also going to need the molecular mass. And this one right here, molecular formula, we don't know what it is. But the mass, it gives us as 78 grams per mole. All right. The next thing we're going to need is the empirical formula. And it gave us that. It should be CH. 1C, 1H. And then there's also an empirical mass. And you can get the empirical mass from the empirical formula, and you just take the C and the H and you find out their mass. So in the empirical formula, there's 1C, which is 12.0 grams per mole, and then there's 1H, which is 1.0 gram per mole, and you add them together, and it gives you a total of 13.0 grams per mole. Okay, so I'm going to put that in here because it doesn't give it to you in the problem. It's hold on a sec. It doesn't. Oh, sorry about this. It doesn't give it to you in the problem, but it is the mass coming from the empirical formula, and so I'll write it down here. 13.0 grams per mole. There we go. So the only thing that we are missing is the molecular formula. These are the four things you need for this sort of problem, where it gives you the mass, you know what the empirical formula is, you have to solve for the empirical mass and to get the molecular formula. Remember, the molecular formula is some number times the empirical formula to get this. So you have to find out what this magic number is, and it's based off of these masses. So however big this molecular mass is, bigger than the empirical mass, is going to be the size, or the same size, as the molecular formula is bigger than the empirical formula. So what they suggest is looks like, well, let me just show you what it looks like. So if you had CH as your empirical, remember it's the simplest form, the molecular is going to be the same, the empirical formula, and each one is going to have a subscript of some number. And so it's going to be Cn, Hn in this case here because the empirical is Ch. So our job is to find out what N is. And how do you find N? Here it is. N is going to be the molecular mass divided by the empirical mass. Okay, so now that we have this here, we can just plug it in, and it's going to be 78.0 grams per mole. I believe it's just 78, but I don't have my book with me. And then this here should be 13.0 grams per mole. You divide this out, and 78 divided by 13 should be 6. Remember, it's always going to be a whole number. You should always get a whole number. So it's 6. 6 is this magic number. So let's go back to this example here. If CH was our empirical, then our molecular is going to be CH with the parentheses, and we're going to have 6 here. You can also have it as C6H6, which is benzene. And that's what we were talking about. That's what the main idea was today. I was talking about benzene, which happens to be some really toxic, nasty stuff. But C6H6 or CH subscript 6 outside of these parentheses is going to be our molecular formula. So I'll erase this little thing here. And then you can write in C6H6. And you know what? If you calculate the mass of this here, it will come out to 78 because there's 6 carbons, which is 12 each, which is 72, and then there's 6 hydrogens, which is 1 each, so that would mean It'd be 72 plus 6, which gives you 78. It's a good check, but this is what the question was for. So I hope that helps out, kids. I'm going to post this, and I'm going to work on the next one for the hydrated crystal, which is our lab tomorrow. So thanks. Hope it's not too late.